Previously, we've been talking about potential differences, the difference in potential between 2 points. So the potential difference from S to T is equal to the potential at point T minus the potential at point S. But we haven't actually talked about how to find the potential at a particular point. Let's do that for the case of a point charge. So here's a point charge with some charge Q. What is the potential at point P, a distance r away from the point charge? We can find the potential at a particular point by thinking about the potential difference between some point infinitely far away and point P. So in order to find the potential at point P, I'm effectively integrating the electric field from some extremely distant point all the way into point P. So the potential at point P is equal to the potential difference between infinity and point P, which would be the integral from infinity to that distance r of the electric field. By convention, we say that the potential infinitely far away from the point charge is 0. And so we're taking the difference between 0 and the value of the potential at point P. The electric field due to a point charge is something that you know how to find already. It's equal to 1 over 4 pi epsilon naught times the charge of the point charge divided by the distance where you're measuring the field squared. If I integrate in along the path directly from infinity to point P, the electric field and the path I take are parallel to one another, so I can treat that dot product as a simple multiplication. This integral is one that you've seen already. The result that you get is that the potential at point P is 1 over 4 pi epsilon naught times the charge divided by the distance where you're measuring the potential. Notice that this result could be a positive or a negative number, depending on the sign of your charge, but it is a scalar, not a vector. It has a sign, plus or minus, but not a direction.